Hello guys, today we are going to create this 3D scan post-processing material. So let's get to it. First things first, we're going to create our post-process material by coming to the content drawer and creating a new material and calling it anything you like. I'm gonna call it BP 3D scan. And right when you open it up, you're gonna come to the details panel and in the material domain set it to post process and come down and make sure to select scene color after tone mapping. Okay, so first, before we start anything, I'd like to clarify some concepts in 3D rendering. The depth buffer that we are going to use usually stores the distance from the camera plane, which is the Z depth, and not the distance from the camera lens, which is a radial distance. The problem is, if you look at a flat wall straight ahead of you, the pixels at the center of the screen have a smaller value than the pixels at the corners, even though the wall is flat. If you blindly use depth to draw a ring, the ring will look curved on flat surfaces, thus creating a sort of fisheye distortion. So we are going to have to fix that problem, and we are going to start with a CameraVector. And make sure you pick CameraVector WS. Basically, this node is a vector representing the direction from the camera to the specific pixel being rendered. You can visualize this as imagining thousands of arrows shooting out of your eye, and the arrow hitting the center of the screen goes straight, and the arrows hitting the corners go out at an angle. The other thing we are going to need is a camera direction vector. This is going to be the forward vector of our camera, where the camera is actually facing. And this is going to be our reference for the camera vector. And now we need the dot product of these two. Basically what the dot product does is it measures how much the camera vector aligns with the camera direction vector or the straightforward vector. And at the center of the screen, the vectors match perfectly. So the angle is 0, which means our dot product is going to be 1. And at the edge of the screen, the vectors are at an angle, so it is going to be less than 1. And so this is where the magic is gonna happen, because we are adding our scene texture and set this to SceneDepth. And after this, we are going to mask the color of the SceneDepth to the RGB values. And once you've done that, you can divide it by our dot product. So by dividing the scene depth by this dot product down here, by dividing scene depth by this dot product result, we are mathematically projecting the adjacent side of the triangle onto the hypotenuse. This converts depth into true distance. So now that we're done, now you just get a multiply node and get a camera vector, and then we are going to add this whole thing to our camera position in world space, and we are done basically with our true distance calculation. So this is our true distance here, and basically our new position, which is this whole thing, we are taking the camera position and adding the direction, which is the camera vector, and the true distance of every pixel on the screen. So now we have all of the XYZ coordinates of every pixel being rendered on the screen. And now, for the sake of keeping everything tidy, I'm going to collapse these nodes into this little collapsed node, which I am going to call new position, and I'm going to click on the plus sign here at output pins, and I call this new position, and then connect the add nodes output to the output node. Okay, so with the first part done, we are now going to move on to the pulse logic. So once we have the 3D position, we need to draw shapes using scalar or single number math. So we will need the distance node, and for the A input of the distance node, we are going to have the new position, and for the B input, we are going to have the camera position. Nice. So now we have calculated the distance from our camera to our pixel position on the screen. Next step is to create the pulsating effect or the radial expansion. We are going to need a time node. We are going to need a time node, but this time node is pretty slow in itself. So we are going to multiply this by a scalar parameter, which you can create by holding the S button on your keyboard and then pressing the left click. You are going to need a pulse speed parameter, which I set to 3000. I think this is pretty self-explanatory what this does. And then we are going to need a new node called fmod, and this is basically a remainder division, and in coding you use the percentage sign for this. So what this fmod does exactly is time is going to start from 0, of course, and it's going to start counting up, and whenever the time calculation hits the 6000 mark, or actually the 6001 mark, it is going to start over. So when time hits 6001, the fmod node is going to snap it back to 0 and starting over the cycle. Now we connect these two logics together by a subtract node like this, keeping everything tidy here. And then we are going to take an absolute value node, which his only job is to turn negative numbers into positive numbers. That's the only thing it can do. So after the absolute value, we are going to divide. Divide by what, you may ask? Another scalar parameter, actually, which we are going to call pulse width. As you might guess, the pulse width value is going to dictate how wide each wave is. So if you set this to 1000, maybe, then the wave, this is expanding from the camera, is going to be 8000 pixels wide. And we only have a couple of nodes left. If you preview this now, as you can see, everything is white and our wave is black. Now this is bad because we want the world to be black and our wave to be any color we want. So we are going to flip this with a 1 minus node. After that, we are going to give the color to our scan, which is just multiplying this whole logic we created here by a 3 vector, which you are going to create by holding the number 3 and left clicking. And after that, let me do this again. After that, you right click and press convert to parameter, so you can set it outside of this blueprint. And you can call this scan color. And as a default value, I'm going to give it red, but you can give whatever you want. If you want to get real matrixy, you can give it green maybe. Actually, let me keep this green. And you wouldn't believe it, we are done. As you can see, when I plug the result of the when I drag the result of the as you can see, when I drag the result of the when I drag the result of this into the emissive color, our beautiful scan is complete. So now all you have to do is place this inside of your world, which you are going to do by coming here and adding a post-process volume, and in the details panel of this volume you're going to search for unbound. Once you press that, you're going to search for material, and in the process materials array you're going to add an asset reference, and from your content drawer you're going to drag your scan material onto. Once you've done that, we have this really cool scanning effect. That's going to be it for today. I really hope you liked this tutorial. Let me know in the comments if there was too much explaining or if there was too little explaining. Let me know in the comments if you want to see more tutorials, and like and subscribe if you want, and thanks for watching.